Okay, so we are now live on YouTube, and we got about 30 seconds till I invite people. Looks like we got 10 people in the waiting room that'll join right away. And I'll have that poll ready as well. All right, I'm gonna go ahead and admit these people in. All right, hello everybody, hello. Looks like we have quite a few people joining here, so I'm just letting everybody in. Hopefully everyone's having a great Wednesday. Long weekend coming up with the 4th holiday, which is exciting. What I'm gonna do, we're gonna try something that we've been doing the past few webinars. I'm gonna start a poll right now and just ask a really simple question about base plates and how often you guys are doing them. So I just went ahead and launched this poll. If you guys have a minute while we're waiting for people to join, just feel free to respond here. You know, how often are you designing steel base plates? Daily, weekly, monthly, a few times a year, or really never? If it's never, maybe it's something you'll do every couple of years at most. It looks like as of now, monthly and a couple times a year is winning. We've got a few people coming in for weekly here. A couple times a year now is winning. I'll give this one another 15 or so seconds to let everybody throw their answers in here. Still monthly looks like it's winning at 45% here. All right, so I'm gonna go ahead and end this poll because we've had quite a few people join. Thanks for everybody for answering that. That's really good information for us to have and the engineering team to bring back. I'm gonna go ahead and share those results as well. But today, we're gonna be talking about base plate design. So Eva's gonna run us through a short overview and a complete example. Thank you again, everybody, for sending through your thoughts in this poll. And then also, as we always do, feel free to say hello in the chat box if I can talk. Where you're joining us from, your title, engineer, architect, building designer, permit reviewer, anything like that. Feel free to send that through. And yeah, we can go on to the next slide here. So you guys have seen this once, you've seen it 1,000 times, about ClearCalcs.com. If you're unfamiliar, ClearCalcs is a cloud-based platform helping engineers, architects, building designers, permit reviewers design and analyze using powerful FEA tools. And we like to think easy to use tools for wood, engineered lumber, steel, cold form steel, concrete, aiming to be more accurate. We want to eliminate wasted time, and I use these examples all the time, but I'd say our most popular one is the load linking feature. That'll save you hours per project, at least we hear from our users. And then we are available everywhere. So whether you're at home, at the office, on site, laptop, tablet, phone, you'll have access to all your files. So how to ask questions here. It looks like we accidentally put in the GoToWebinar screenshot there, which is completely fine. But if you guys are unfamiliar with Zoom, click on the chat box. And then what you could do is ask your question in the chat. You can select either everybody if you want to send that question to everybody, or if you want to just send one to me, or just send one to Eva, or if you want to have a little side chat with one of your buddies who's on this, you could do that as well. But send any questions throughout. We will have a 15 to 30 minute Q&A at the end answering all these questions, just depending on how much time we have left. So we'll make sure to get to any and all of those. And we could pop onto this next slide as well. Last slide here before I kick it over to Eva. Meet the presenters. Hopefully I've met most of you guys. I see some familiar names in here. I'm our Director of Customer Success. Here to make sure you're successful in ClearCalcs, whether that's before or after you sign up for ClearCalcs through a training session, help videos, support content, anything like that. And then Eva, she's a structural engineering developer here at ClearCalcs. She's assisting in developing the calculator content in the US and Canada, and she has years of consulting experience as well.
Yeah, thanks for the intro, Connor.
Yeah, no problem. Take it away.
Awesome. Yeah, hey everyone. Thanks for joining us talking about baseplates. So a general overview of what we'll be talking about. So what is a baseplate? Why are they important? The forces acting upon it and the consequent failure modes. Then we'll talk about a little bit about designing against those failure modes, and we'll go through a worked example in ClearCalcs. Yeah, and feel free to ask a question at any point for clarification. So starting at the base is what exactly is a base plate? This is actually from a couple of years back, a project I had designed. A base plate is basically, typically it's a steel plate under a steel column, and it acts as the interface between the column and the concrete below, whether that's the concrete footing or a concrete pier or a concrete wall. Actually, sometimes can anchor them into walls as well. And why are they important? So they're important for two reasons. On the engineering side, they're important for load distribution because your base plate is typically larger than your column, and that increases the lever arm of which reduces the couple force that the anchors need to hold on to. But also it just makes construction easier. If you've been on a site, you know that leveling concrete is not the easiest of things. And the other thing is just when a project starts, you start with a large hole in the ground. And then as you build up into smaller and smaller, into like further and further up, the tolerances get smaller and smaller. So a base plate actually helps set a set amount of tolerance between the foundation and the column that needs to be a lot more accurately placed. So yeah, for these two reasons, they're quite important, and we see them used almost in all steel concrete interfaces. So the forces acting on base plates are plate bending. So the plate itself undergoes bending. And if you wonder, like, oh, how does actual force cause plate bending? If you imagine a plate and there's an actual force acting on it, you can see that like the plate will bend in the middle and then come around on the side, and the two ends will come up. And then other parts of the plate is to what actually holds the plate down to the foundation and prevents it from sliding around or lifting off is the anchors. So two forces that act upon the anchors are shear. So if there's any horizontal force in the column above, your bolts will really be, your anchor bolts will be what prevents the whole system from sliding off your foundation. And then when there's any overturning moment, so you can see in this example, if your column plate assembly wants to turn, the moment will decouple into the set of anchor rods, and one of them will be in compression. The compression will be mainly taken by the concrete, but the tension is almost completely taken by the anchors and its embedment into the concrete. So the anchor could, so it's important to design the anchors so that they don't yield in that case. And speaking of yielding, these are kind of the failure modes that the base plate and anchor can experience. So on the left, we can see when the plate yields, it then is no longer acting, it's no longer transferring forces between the column and the foundation as it's supposed to, because now it's, now the plate is no longer flush, and it's now not transferring the full amount of force. And then ways that the anchor can fail is it can be pulled straight up, just pulled out of the concrete below, or the bolt itself could yield. The anchor itself could yield, or it could be sheared right through. So if it fractures or yields, then we consider that a mechanism and it's no longer transferring the forces or doing its job. Another thing I think, because it's on the picture and should be considered is the connection between the column and the plate. We won't talk about that too much further, but typically they're welded in that case. And just to ensure that there's enough connection between the column and the plate to prevent that from failing. And then, so speaking of the anchor pulling out, we know that the foundation and the concrete below the base plate also plays an important role to preventing base plate assembly sort failure. And so there are failure modes for anchors with the concrete has failed. So if we consider just tensile forces on the anchor, we can see that it can be the steel failure, or it's called cone failure, concrete breakout, where a cone kind of forms around the anchor and then the entire concrete just lifts out with the anchor. And then there's also blowout and concrete splitting. So these are all potential failure modes when the anchor goes into tension. And then there are other failure modes of concrete when the anchor has side forces. So if it's too close to the edge, that whole side it's called concrete breakout, and that whole edge distance of concrete could just end up breaking out along with the bolts. And even if it's not too far, even if it's far enough from the edge, it can also break out if the anchor isn't embedded deep enough. So if you have a shallow anchor, there's not enough concrete kind of to keep it gripped within the foundation, then you can see the second failure mode is that it takes a chunk of concrete off, and then that transfer force is no longer engaged. So how do we design against base plate and anchor rod failure? So the plate itself is quite straightforward. To prevent the plate from yielding, you basically ensure that the plate has enough thickness. So based on the force, we'll size the plate to an adequate thickness. And for the anchor rods, to prevent pullout, what you can do is hook the anchors. So if you hook, which it's making an L shape at the bottom, if you hook them, then they can grip more concrete, and that kind of can help prevent them from lifting out, or adding an anchor plate. So I added a picture here. It's a little small, but basically it's a plate added to the bottom of the anchor to give it more grip. And then to ensure that the anchors will not yield or shear, is basically upsizing the anchor rods themselves. So they'll come in a variety of sizes. You can check if the size is enough for the force you're looking to design for. And then how we design against concrete failure. So I guess I alluded to this a couple last slide, but if to prevent against shear from the edge, simply offsetting the anchor from the edge of the concrete will help with that. Using a higher strength concrete, adding confining bars, or increasing the length of anchor so that the boat has more concrete to grip onto. And so for designing against base plate and anchor failure, this is what we as ClearCalcs will check. So for the plate yield, we'll calculate the minimum bearing thickness and report the maximum bending capacity. And then we'll also calculate anchor tensile capacity, anchor pullout, and anchor shear capacity. And for the concrete, we'll calculate concrete breakout, concrete breakout, and shear breakout. And just before I get to the worked examples, I'm just going to go over what it looks like in ClearCalcs. So you can find our steel base plate calculator to LRFD here under connections. And let's go ahead and open one up. You see, this is the 7th one I am now designing. And I'll go over kind of the parts of our calculation. So this is we'll input our parameters. I will say actually hold off, other than the yield strength and the concrete strength, hold off on inputting any of the other parameters, as we actually dynamically calculate them based on the force that is being inputted. And then here we have the anchor rod properties. So depending on if you want to check for pull out, breakout, and pry out, all the great things we just talked about, you can click yes. If you're not worried about that, or if you're anchoring into something else, you can toggle that off. You can toggle that check off. And then these are kind of anchor rod sizes and anchor rod grade, as well as straight or hooked. And we spoke about how hooked gives you more grip to prevent pull-out failure. And then these are concrete properties. So how much cover you want between, it's required minimally between the anchor and the edge of the concrete that you're embedding into. So we'll do a check and ensure basically that it's at base per code. It needs to be at least 1.5 inches. And typically I'll start with that. If more is required, I'll consider that in the design. And then we also have features for including friction capacity and grout capacity in the check. If you're confident of that, that's something that will help, like it will help, but if you're confident in the construction that it will be fully engaged, then this will give you a little extra capacity. So it's more conservative to leave it as no, but if you know that that you have full friction contact, you can consider that force as well. And then here we have applied loads. So very similar to all of our other templates, you can apply loads by clicking edit here. And in this case, you can apply loads about the x-axis or loads about the y-axis. And then we'll move on to these sections that we talked about for checking anchor tensile capacity, pull-out capacity, and then we'll check shear capacity here. And then we also check concrete breakout, side blowout, pry out, and then shear breakout. So the difference between breakout and shear breakout is one is due to tensile force and the other being due to shear force. And in the summary here, we'll report the maximum loads, maximum moments, and then like all of our calculators, the traffic light checks. And so, yeah, I believe Connor is looking to pop up a poll, and we'll do that first before we move on to our worked example.
Yeah, appreciate it, Eva. Like I mentioned, just want to make these things more interactive and include some polls in between. So I'm going to go ahead and launch another poll here. Piece of information here that our internal engineering team is super keen on understanding. What is the most painful part of your base plate design? I know a lot of you guys said you're doing it either weekly or monthly, so it might not be a day-to-day thing. But yeah, we've got quite a few responses coming through. It looks like we have 1 for finding the plate size, so far 2 for designing the anchors, 3, 4 for designing the anchors. And then we've got 6 so far for non-standard configurations. So like we were talking about the other day, Eva, I believe, not having 4 bolts at the corners. So maybe I might send something in the chat here as I kick it back to Eva and we start to work through this worked example. Curious to learn more about what those non-standard configurations are, if it's 2 bolts, if it's more like 6 bolts, or I guess even more than that. Yeah, curious to learn a bit more, but thanks everybody for participating here. I couldn't think of that word. I'm going to go ahead and end the poll so we can kick into this worked example. Then I'll go ahead and share the results just so all you guys can stay aligned there and have an idea of what everybody else said. But back to you, Eva.
Yeah, cool. And thanks for participating in the poll. Really, like we build our features based on feedback from users like yourselves. And so, yeah, it's great to know what you're looking for. So just heading back to the example, just going to read it, but we're designing. So it says we have a W12 by 96 column and it bears on a 24 by 24 concrete pedestal. And it gives us the concrete compressive strength of 3 KSI, the base plate yield of 36 KSI, and then it wants us to determine the base plate plan dimensions and thicknesses for that given strength. And since we're designing an LRFD, the factored load we have here is an ultimate load of 700 kips. Let's head back to our design. And so we have a 12 by 96. So we know what column they want. So that one we just put in. And then based on these, actually we'll update the dimensions to ensure that the plate is geometrically accommodates for the column you're putting in. And then from there, we know that it's the compressive strength is 3 KSI. So we can actually just put in 3 KSI here. And we'll do, ClearCalcs will do the conversion. The Fy is 36 KSI, so that's correct. And then we'll look, and then the forces. Scrolling down, that's the important part. Since it's factored to 700, and I know that dead load is an LRFD is factored to be 1.4 for dead load. So what I'll actually just do is here is put in 700 kips and then divide that by 1.4. So that when we see the force applied PU here is 700 kips. That's just given the requirements for like when you design these, you can input the unfactored forces and we'll factor them for you into LRFD. And so we'll see here that actually these dimensions have all changed, which is why I had avoided changing them earlier on. But we know it's sitting on a 24 by 24 pedestal. So I'll update that to be 24 by 24. And then it'll actually change the required plate length and required plate width. Obviously 21.7 is not an ideal spec. So we can up that to 22, and then we can up this to 20. Or if you want a square plate, you can change this to just 22 by 22. And then we can see here that we have that our governing moments, our governing factored bearing length, our governing moment, as well as the total tensile capacity. And if we scroll down, we can also check that the pure actual capacity is at 87%, and we're not at risk of breakout or blowout, which makes sense since this is only actual force acting downwards. And then here we'll size the base plate to the minimum amount. It's 1.83. Typically, I understand plates come in 1/4 inches, so I might round that just to 2 inches. And then we can see that the summary up here, we have a 22 by 22 by 2 base plate with four 3/4 inch anchors. And we'll see our utilization for bearing strength, moment, as well as tensile capacity. So yeah, that is for just a pure actual load. I know you're probably wondering, what if I have non-actual loads? Oops, sorry. Let me just pull up the next worked example. What if I have a moment on my base plate? So this example asks us to design a base plate for actual dead and live loads equal to 100 and 160 kips. And the moment from the dead and live load are 250 and 400 kip inch, and then bending about the strong axis. So it's the same, it gives us the same column size. And then Fy is 36 KSI and F prime C is 4 KSI. If we head on over, we can start a new calculation. And we can do the same thing here. So we'll start with our W12 by 96, because that will just give us nice geometric dimensions, the minimum geometric dimensions we need to accommodate this column. And then from here, so these forces were given unfactored. So I'll put in 100 kips for dead, and then 160 kips for live. And then they also have 250 kip inch for dead and 400 kip inch for live. And so that's our forces inputted. Our cover is usually like to go for minimum cover because that gives us more lever arm space. And then we'll scroll up just to see what the thickness and plate design and the plate design dimensions given are. So it seems like if we have a 17.7 by 16.2 plate, that it will pass in bearing and moment and tensile. But it looks like it's saying that the bearing area is exceeded. So it seems that we've designed the most optimal plate here for these criteria. But if we scroll down here, it looks like we need just a little bit more bearing area. So we can update this to be 18 or 20. Let's try 18 first. If we use an 18 by 18, it seems like base plate dimension still needs to be increased. Add to that a little. And we can see here now that we no longer have, now it no longer fails in bearing, but now the plate is just passing or just failing in bending. So the final thing we can do is we can increase this just a little bit more iteratively and see. And then we can also increase the base plate thickness because we know that we want to avoid it yielding. So maybe to 1 3/4 of an inch. And then we can see that now everything passes. And so for this voice, we can design a 21 by 21 by 1 1/4 inch plate with 4 3/4 anchors. So to recap, a base plate interfaces between what's typically a steel column and a concrete foundation. The base plate distributes loads from the column into the foundation and provide the level surface for the columns. And anchor bolts attach a base plate to the column, and forces acting on base plates and anchor bolts include bending in the base plate and shear and tension in the anchor bolts. And there are various failure modes of base plate, anchor bolt, and the concrete that it anchors to that needs to be designed against. And we'll check those in ClearCalcs. And the last thing I want to bring up is this reference list. I know to those of you who have attended our webinars, I know we're getting around to creating a cheat sheet of sort for kind of these references that go into our templates. And so this is kind of me starting one for this particular template. But if say you want to go back to like the minimum one, you can put back in calc. And then it'll bring you back to the minimum specified plate length. And so that's how we revert back to that. Okay. I do not know how to flip between PowerPoint correctly. Yeah, happy to take any questions or comments or suggestions.
Yeah, thanks, Iba. I thought it was a good example working through the different iterations and, when you're failing, what you want to be messing with on this, the base plate to get it to pass. I did have one question from James. He was wondering if at current time, if you could use this base plate calculator to design embedded base plates with weld studs.
So in this current iteration, we wouldn't, that wouldn't be possible. I think simply I'm thinking from types of failures. So with the weld studs, the weld is a point of failure that we'd want to consider. And then with embedded base plates, and then the concrete is engaged in a number of other ways. So I would advise against designing that in the current iteration. But if that's something you're looking for, please send us a feature request and we're happy to look into it.
Awesome. Yeah, good question, James. I know just connections in general has been something that's come up. So get into those, checking those welded connections, something we're definitely interested in. Also, thanks, Nathan, for sending through your non-standard configuration. So not having just 4 and 4 corners, but it looks like you have 8, so 4 in the corners and then 1 at each midpoint. I know I've seen that quite a bit as well. I'm sure a lot of you other guys do that. No other questions at the time being. If you guys do have questions, feel free to either unmute yourself or send it in the chat here. While we're waiting on those, just because I'm awkward and don't want to have just awkward silence, figured, Eva, we can go to the next slide and just start touching on these final slides here. And again, definitely send through your questions, suggestions, recommendations in the chat here, and we'll be sure to touch on them. But for what's new in ClearCalcs, always want to say this in these sessions. So the new calculators we've released recently are our diaphragm analysis. So if you guys have checked that out, it's not only just a diaphragm analysis calculator, but Eva and the engineering team have also released the ability to link between calculators. So if we're looking at, say, a wind or seismic calculation in ClearCalcs, you could take that wind or seismic, link it into your diaphragm, and then link that into your shear wall, for example. I know I've gotten that question quite a bit, so that's something that is now possible in ClearCalcs. We do have custom wood sections available. So if you're dealing with a completely custom wood section and you want to go that route, you could do that as well. And then Eva and the engineering team have released open web steel joists. So that is a calculator in ClearCalcs now. And then we have quite a few in the pipeline that Eva and the team are working on that should be released in the coming weeks, which we're super excited about. Finally on this page, so if you are working on a team and you're working in light commercial design, let me know, shoot me a direct email if you're interested in helping us shape ClearCalcs at all. We're trying to schedule these discovery sessions. Like Eva mentioned earlier, the way we can improve ClearCalcs is by connecting with users and what they need to see, learning their workflow, so that way we can create the best types of calculators for you guys. So shoot me an email if you're interested. But it looks like we've had quite a few questions come through. One question from Bobby, Eva, is what about the grout beneath the plate? Do we do any checks for that? Curious to hear your thoughts.
We will make considerations for it. So we have a toggle for considering grout for friction and actual capacity. So the grout will add some capacity, like some amount of capacity, and we do consider that. As for, yeah, can I ask if that answered the question, or was it more about like the grout strength required?
Yeah, let us know in the chat, Bobby, if that did answer your question, or feel free to unmute yourself as well. For the time being, I'll jump on to the next question, but let us know, Bobby. So Nathan asked if the calculator for base plates currently has an option for stainless steel bolts. Good question.
Yeah, you can check. You can check if we have if we offer that grade or that type of material. So it seems like at this point, we're referencing ASTM and only ASTM grades. I believe stainless steel is a different ASTM. So not currently. Yeah, please feel free to let us know if that's something you're looking for, if that's something you work with often, and like kind of the use case there. I think we're happy to build features around that.
Yeah, good call and good question there, Nathan. Matt, thanks for sending through. It looks like a non-standard base plate configuration there. Thanks for sending that through. And looks like we answered Bobby's question, so good call there, Eva. As of now, that's all the questions we have, everybody. the last thing, I guess we could just jump onto this last slide here. So for everybody's reference, so we will send everyone a recording of this webinar by email. So if you attended, if you registered, you'll get the email. We also do have on our ClearCalcs main page just all of our past recordings. I then want to jump back into a question just so I don't finish this up and then we end it. So Nathan asks, does the calculation address prying forces on the base plate?
On the plate itself, like if something got wedged in between and it was prying it up, can I just clarify that?
Yeah, Nathan, feel free here. I'll look you up in this chat and see if I could just unmute you. And that way we can make sure to have your question answered.
Yeah, just prying, like from overturning, prying between the bottom of the plate and the concrete itself.
So we will check for, I guess, if there's overturning of the plate column assembly from any forces, we'll check that the anchors are adequate. I guess for prying of the plate itself, I probably have to get back to you, but off the top of my head, we hadn't considered that quite yet. Can I ask what instance it comes up in?
We do a lot of like circular large center columns that are supporting wastewater treatment equipment.
Mm-hmm.
So we have to look at prying action there. It's not necessarily base plate yield.
Right, yeah, like this will check concrete pry out, as well as, seems like, yeah, for this one, just the pry out for concrete. Yeah, feel free to shoot us an email about that, like about your specific use case, and I'm happy to have a look at it.
Okay.
Thanks.
Yeah, thank you, Nathan. Thanks for unmuting and asking that. Yeah, we could hop back into the last slide here. For everybody's reference, hopefully you know this already, but if you do have questions, suggestions, anything like that, like we've been getting, it looks like it's on this slide. You could send an email to help@clearcalcs.com. What that does is send emails directly to myself. I get those, and then we take one of our structural engineers 6 days a week. Could be Eva, could be one of our other structural engineers. All they do is respond to those questions and suggestions. So that's the best way to get a hold of us. I'll make sure to stay on here for another minute or so, just in case any questions come through. But if we end this and you guys are falling asleep tonight and you're like, dang, I wish I would have asked that question, send it to help@clearcalcs.com. That's the best way to get a hold of us. And really appreciate everybody joining. Hopefully everybody has a good holiday coming up, a good long weekend. Stay safe. Enjoy the time away. And thank you, Eva, for running the session.
Yeah, thanks everyone for joining me.
All right. I'll go ahead and end it. You guys have a great rest of your day.